Lesson 6-8, dilations, one of the last proportion things. It's mainly either blowing stuff up or shrinking things. The word dilation, by the way, it's D-I, not D-I-L or D-I-A. It's dilation, just leave out the A. Makes it bigger or smaller. Now, where have we been so far? We've been so far like with this. To make a translation, you take a shape, maybe something like this, not quite a square, and you move it. You keep the same shape, you just move it up or down, left or right, nothing else. You could rotate it. You could rotate this shape. Maybe take this and you rotate it. We always rotate it 90 degrees. And you turn it over on its side. Maybe it comes down here, upside down. Rotate, flips it around. Easy to spot. Probably the easiest one to spot, besides translation, is reflection. Reflection does exactly what kids think it does. If you have a shape like this, it reflects. It reflects. It's a mirror image. Left and right, flipped over. Well, what's dilation? Dilation is the only one that actually makes it bigger or smaller. Translation, shift, move over. Rotate, okay, rotate it around the center of a circle, center of a point. Reflection, flip it. Dilation actually makes it bigger or smaller. Probably the best example, for you anyway, at schools, copiers. Copiers. Copiers make it bigger or smaller. Enlarge, decrease. If you put it at 75%, it decreases. If you put it at 125%, it increases. There's always some kind of scale factor. Scale factor, just like in the other sections. Proportion, it's proportional. We're going to make it bigger or smaller. By the way, before I forget, I got a gum box for you. I brought it today from home. Gum box. Yeah. Sorry, no gum. Everything was made proportional. Sorry. Proportional. So that it looks exactly like the small gum box, the gum package, but it all had to be measured and proportioned. Everything was done scaled. Well, the book only gives one kind of scale factor. It has to do with the coordinates. Let's say you have a triangle. 4, 2, 3, -1, 2, 0. Coordinates, x, y, left and right. If you have a scale factor, by the way, they give you a scale factor. They usually... Okay. Oh, just disregard that. Sorry about that. I'm not going to cover that up. Scale factor. Let's say it's a scale factor of 2. It's very easy. It's very easy. Everything's just doubled. Instead of 4, 2, they now go out to 8, 4. Where's 8, 4 at? Up over here. 8, 4. What does this one become? Transform. It becomes a different shape. Double this. 6, -2. 6, -2. 2, 0 becomes 4, 0. It transforms it. That's a terrible drawing, but that's a terrible drawing. That's why you got to have paper with graph paper and stuff. What's the point? The point is, all you do is double it. What happens if you have a scale factor of 1/2? All you do is take everything times half. Everything. X and Y. Does that make it half as big? Actually, it makes 1/4 of a big because it's half this way, half this way. So, the scale factor that they talk about, K, just multiply the coordinates. Take the X times the scale factor, twice as big, 3 times as big, half as big. Then you graph it. That's all we're doing. It's the 4th kind of transformation there is.